Okay, this tutorial is just going to be a brief review of energy flow in an ecosystem involving photosynthesis and respiration. So before we get to that, let's review the first law of thermodynamics, which states that energy cannot be created or destroyed, but it can be transferred from one object to another and transformed from one form to another. So that's a rule of the universe. And then you get this statement, and so I ask my students, is this true or false? You've seen this statement before. The mitochondrion is the powerhouse of the cell because it makes the energy that the cell needs. The problem with this statement, and what makes it false, is this concept of it makes the energy. Because the first law of thermodynamics says energy cannot be created. And so what the mitochondrion actually does is perform the transfers and transformations of energy that occur in the cell. So if I had to define photosynthesis, I want to focus, and respiration, I want to focus on this concept of transfer and transformation of energy, not making energy. So photosynthesis is the transfer and transformation of solar energy, so sunlight in our case, and it's transferred and transformed into chemical energy. And when we talk about chemical energy, we're typically talking about the bond energy of organic compounds. So solar energy, sunlight energy, is transferred and transformed until it is contained in a compound like glucose. So we typically talk about carbohydrates. Now, it can also be other organic compounds. But initially, glucose is one of the first products of photosynthesis. Now, respiration is also a transfer and transformation of energy, but it's the transfer and transformation of chemical energy that comes in the covalent bonds of carbon compounds, organic compounds, and then the energy is transferred and transformed until it is held in the in the covalent bonds of another compound like ATP. So the energy is transferred from organic compounds like glucose and then transferred and transformed into the bonds within ATP. Now, so both of these processes are about energy transfers and transformations. Photosynthesis happens in a different organelle than respiration in eukaryotic cells, but they're both dealing with the transfer and transformation of energy. So ultimately, you end up with these overview equations. And if you look at these overview equations, if you focus on the energy transfers and transformations, what you would focus on is the sunlight, because the sunlight is the original source of all energy, or 99% of energy on Earth. And the sunlight energy, remember, is transferred into the chemical energy in the bonds of the glucose shown here. Everything else in this equation is not energy, but rather matter. So the energy is in the bonds of the glucose, comes from the sunlight. The matter, the atoms, come from carbon dioxide and water. And then there's a waste product of oxygen. But if you focus on the energy transfer, you're really looking at these two these two items, sunlight and glucose. And then the glucose, the energy in the bonds of glucose, can then also be transferred into the bonds of ATP. And so you would focus on these molecules. And so this is the energy flow from sunlight to glucose and from glucose to ATP. And then the energy in ATP is used by the cell to perform every function it needs to perform practically, until ultimately the energy is released from the cell as heat. And heat is typically the final form of energy. It can't be recaptured. It can't be transformed or transferred, and so it's considered a waste form of energy. So that's the flow of energy in an ecosystem. And that's a connection that I'd like you to be able to make.